Optimisation. Example 10.15. 4 meters of wire is to be used to form a square and a circle. How much of the wire should be used to make the square and how much should be used to make the circle in order to enclose the greatest amount of total area? So the first thing we know is that we've got 4 meters of wire. And we know we have to make a square and a circle. So I'm going to call each length of the square x. The circle has a radius r. So we want to maximize the area. So the total area is x times x, which is x squared, plus pi r squared. We're going to use 4 meters of wire. So we know that the total perimeter is equal to 4x plus 2 pi r. But we know that the perimeter has a maximum of 4 meters. So therefore 4 is equal to 4x plus 2 pi r. I'm going to rearrange that to find r. So we got 4 minus 4x over 2 pi is equal to r. I'm going to divide every term by 2. So we get r is equal to 2 minus 2x over pi. I'm going to factorize the top. So I get that to equal 2 lots of 1 minus x over pi. As I'm maximizing the area, I can now substitute back into the area function for r squared. So I've got ax is equal to x squared plus pi times 2 lots of 1 minus x all over pi squared. Right, I'm now going to multiply out my large bracket, so I get a of x equals x squared plus pi lots. 2 squared is 4. 1 minus x squared over pi squared. I can cancel the pi's, so I get a to the x is equal to a squared plus pi's cancel. So I get 4 1 minus x all squared over pi, as 1 is cancelled. I'm now going to multiply out my bracket, so I get a to the x equals x squared plus 4 lots of 1 minus 2x plus x squared all over pi. I'm now going to multiply out the bracket, so I get a to the x is equal to x squared plus 4 minus 8x plus 4x squared, that part all over pi. Multiply the first term by pi so I can get it over the same denominator. So I've got pi x squared plus 4 minus 8x plus 4x squared all over pi. We have 2 terms with x squared, so I'm going to factorize that out. So I get a to the x is equal to x squared pi plus 4 plus 4 minus 8x all over pi. Now I need to differentiate, so a dash of x is equal to 2x times pi plus 4. Remember, pi plus 4 is just a number. The differential of 4 is 0. Differential of minus 8x is minus 8 all over pi. I can now put the differential equal to 0. So 2x pi plus 4 minus 8 all over pi is equal to 0. Multiply through pi, so I get 2x pi plus 4 minus 8 is equal to 0. Take the 8 to the other side, so I get 2x pi plus 4 is equal to 8. Divide by pi plus 4, so therefore I get 2x is equal to 8 divided by pi plus 4. Therefore, x is equal to 4 divided by pi plus 4. Therefore, if you put that in a calculator, you get x is equal to 0.5601. Right, that is a critical value, but there are other critical values. If we go back to our diagram, we've got a square, sides x, and we've got a circle, radius r. Our other critical values are the maximum value for x is 1. Because if we use all 4 meters on the square, the biggest value for x is 1. If we use none of the wire for the square, the smallest value is 0. So we must test A0, A0.5601 and A1. If we put those into the calculator, we get the following values. A0 is equal to 1.273. A0.5601 is actually equal to 0.5601, and A1 is equal to 1. That means that the greatest area is if we use none of the wire for the square. So therefore we want no square. We want all the wire used on the circle.